First we have a video of us skipping stone rocks. Alright.
Okay, so we initially found a function of a rock skipping, and so we decided that we would create our own function of a rock skipping across water. And so we knew that we had to make the function an absolute value function because the rock does not go underneath the water, it stays on top, it's positive the whole time. We also wanted to use cosine because that is like a repeating like jumping motion, and then we wanted to make it piecewise because the rock is not going to be like the same skipping every time, it changes.
So this is our function and our graph for our initial toss. It's y equals 20 absolute value cosine x from 0 to pi over 2.
The first jump is y equals 2.5 times absolute value of cosine x, and that goes from pi over 2 to 3 pi over 2.
Our second jump is y equals the absolute value of cosine x from 3 pi over 2 to 5 pi over 2.
And then the third and final jump is 3 times absolute value of cosine x, and that goes from 5 pi over 2 to 7 pi over 2.
So this is all 4 of those graphs together. She's pretty.
Okay, so the thing that we had to figure out when we wanted to find our extrema and our concavity is finding the derivative of an absolute value function. So an absolute value is x squared, or the square root of x squared. So to find the absolute value of that, we had to use the chain rule and the power rule. So taking the absolute value of that would be 1/2 x squared to the negative 1/2 times 2x. And then simplifying that, you would get x over the absolute value of x times f prime of x. So when we had to use our cosine function, we had cosine x over the absolute value of cosine x times negative sine x, which gives us negative sine x.
And that's the function of our second jump? Yeah, second jump. So this is our work for all of our first derivative tests. So focusing just on our first jump, we just did our 3 jumps, we didn't do our initial toss. But we found all of our critical values. So for this one, our critical value was pi. And then we did the first derivative test, and we saw that it went from positive to negative, so we knew that it was going to be a relative max. And then we found that value. So for this first jump, we got a relative max at pi 2.5. And our other maxes were 2 pi 1 and then 3 pi 3.
Okay, so then we took the second derivatives of each of our piecewise functions and got the acceleration, and then we graphed it to get the acceleration graph. So the velocity would be negative 20 times sine x, and the acceleration for that is negative 20 times cosine x.
This is the velocity and acceleration functions of our first jump. Our velocity function is y equals 2.5 sine of x. And then our acceleration function is y equals 2.5 cosine of x. As you can see, there's our little extrema.
So where it switches from positive to negative, that's where we know our relative maxes are at. Our second jump, the velocity was y equals negative sine of x, and our acceleration was y equals negative cosine of x.
And then our third and final jump, our velocity function was y equals 3 sine of x, and our acceleration function was y equals 3 cosine of x.
So here is our position function, and then this is the derivative of that, and this is the velocity function. And you can see that at every time where it switches from positive to negative, those are our extrema.
So this is our acceleration functions and our total distance. So for our total distance, we integrated, just for our initial toss, we integrated from 0 to pi over 2, and then we took the absolute value of all of the velocity functions because we're finding total distance. And altogether, we got 26.5 decimeters was how far this rock in particular traveled. These are some of your famous rock skippers. And the Pitch Perfect 2 cast. They also rock skip a lot. Thank you, and thanks for clapping.